Good evening, everyone. My name is Umachandar. I am a program manager in the SQL Server team.
And hello, everyone. Welcome to our session. My name is Sumit Kumar. I am a program manager in the Machine Learning Services group. And together, UC and I, his name is not Umachandar.
Yeah, I put the shortest nickname.
So anyways, so together we build the SQL Server Machine Learning Services that supports Python and R.
Looks like a lot of people are missing. They probably already started on the beer. It's good that you guys are staying here for the session. Quick show of hands. How many people use R today? Okay, about 20, 25 people. Python? Okay, more. And how many use SQL Server 2016? Whoa. Okay, that trumps both R and Python.
How many of you use SQL Server R services in 2016? Sure.
Okay.
And how many of you identify yourself as data scientists in this room?
Okay, about 10. Okay, so whatever we say might be too hard for you to understand for the data scientists. So, okay, so this is the agenda we have. Like, we'll do a quick, introduction on what is machine learning services, what are the scenarios we are kind of targeting, and then we'll also talk about the features just to give you an idea of what were the investments made over the last two releases. I'm sure you heard the 2017 release update today, right? And then we also have a roadmaps slide just to give you an idea of what's coming. Okay, so what is this whole scenario about? You've probably seen a version of this slide with squares, circles. I guess this is a pyramid, so all geometric shapes, but yeah. So this is about like people building applications today within some intelligence built into it, right? Meaning predictions for future things which is going to happen, right? So typically what we see is that logic is built outside the database, right? And it could be in your Excel file. It could be in some R or Python code running somewhere. And we've also seen customers take that piece of code and rewrite it in Java or C++ and deploy it with their application, right? So this obviously has a lot of challenges in terms of development, like turnaround time, and also the other challenges, if your database is really big and your data you need to work with is huge, then you have to do a lot of changes for that, right? So that's one of the big things here, right, today. So we basically want to change that paradigm and basically move that intelligence logic into the database. That's what we mean by saying, like, in database machine learning is take that piece of intelligence which you're writing in R and Python today, and you should be able to take that code, put it in SQL Server, and SQL Server is a very good, trusted, and scalable, performance platform, right? So you can leverage all of the SQL capabilities, and you have the way to run your R or Python code in the database, right? So that's what we mean by like in database machine learning is keep your investments wherever you are, right? Like R or Python, and now you could kind of lift and shift that piece of code into SQL Server, right? And that means wherever SQL Server is running, you're going to be able to use it, and that's something we'll share in terms of roadmap, right? Okay, and also like why R and Python and all of these, right? Like, if you look at the latest KD Nuggets survey, in terms of programming languages used for data science and machine learning, it's pretty much these, right? So SQL is already there, and Python and R are the other big things, and that's what we are like kind of targeting here, right?
So in 2017, we have added Python. 2016 already supported our services. And addition of Python, number one, it sort of now brings the other half of the data science world, which is on Python, brings them in, supports them within database analytics as well. The other thing it does is, there's a lot of innovation happening in the deep learning and AI world in Python. So all of the popular AI frameworks, TensorFlow, Cognitive Toolkit, Theano, Keras, all of those things are only supported in Python. So now, with the support of Python, you can bring any of the open source DL frameworks and make it run on your data that is securely inside of SQL Server. So that's the best of the two worlds working for you.
Cool. Okay, so just to drill down on some of the key benefits of running machine learning in SQL Server, right? So data movement is the big piece, right? So I talked to like Blue Cross like a couple of weeks back, right? So they have like about 1,000 instances of SQL Server running, right? And today one of the biggest challenges is basically moving data around from each of these databases to some central data warehouse or another, right? So some regional office will say, hey, I need this data for my analytics or data science, and now they're like doing all these movement. So they actually want to virtualize a lot of their data warehouse layer in few SQL Server instances. So virtualization meaning like the data lives wherever it is, and you just simply use SQL Server like technology like Polybase and basically get to the data, right? Through DQ, for example, right? So this has many advantages, right? Like one, you can leverage the security policies on the remote destination, right? And the other thing is like if the newer requirements like this GDPR has like, it's very strict, right? So for example, a company can come and tell you like you need to go delete this particular data from all your databases, right? So imagine if you have hundreds and thousands of copies of this data. So now first you have to find out where these copies are, and then you have to go delete it, right? So those challenges can be easily solved by leveraging SQL Server platform, right? So now essentially we're saying like now you can run ML compute closer to the place where your logical data warehouse is, right? And that basically gives you, better access to the data. And then the other big thing is like now you have a SQL interface on top of the machine learning script. So that means any application which can talk to SQL Server can now get access to the data, right? So you can get to SQL Server now from any platform, and we also run on Linux now, and that's the other thing we're working on is getting machine learning on Linux, right? And then the last one is also very important, the performance and scale, right? So a lot of the investments in R and Python is not just about like running the R and Python script in SQL, right? So we made changes to the engine so that if you have a parallel query running in SQL Server, you can also run your R and Python scoring in parallel or training in parallel for a lot of cases. So we'll actually go through some examples of those. And then the other big thing is resource governance, right? So today if you have analytics server where you are running your R or Python scripts, it's really hard to partition the resources on that server, right? So you can't say like, I want to run R on only these CPUs, I want to give this much memory to it, and so on. So, but those policies are very easily done now through SQL Server. So we have an external resource pool, which allows you to just leverage that capability very easily. So it basically moves a lot of these things to a declarative mode, so you are able to use the SQL features and do your machine learning also that way.
So to add to that performance point, not only have we brought open source R and Python to work it in database, to make it work in database, we've actually built on top of open source R and Python. So one of the limitations that you are probably aware of in the open source R world is it being bounded by memory. So what we have done is we have scalable versions of most popular algorithms, because of which you're not bounded by the memory available on the machine. So you can work with sort of basically scale infinitely. You chunk data from disk into memory, and that's how you work on. So the point is, you can, if you're happy with the open source R and Python performance, great. But if you need your analytics to scale beyond that, we have additional algorithms that help you do that. So let's take an example of a customer where, you see next slide. Pros, how many of you are familiar with a company called Pros? So it's an e-commerce SaaS type company that helps companies like airlines to figure out what is the right pricing strategy so that their overall revenue is optimized. So one of the problems, among others, is to do segmentation, or basically classification of the customers into different groups. This is a typical machine learning problem. Next slide, you see. So what they had in the past was, and this is a typical story that we hear from a lot of our customers. They have data scientists sitting in one part of the organization. They have IT folks who control the data sitting in a different org, and then developers somewhere in between. So the data scientists used to get pieces, chunks of data from the database, database folks in CSV files and other formats. And then they would train their model, and they would often have to sort of build the infrastructure to move the data, stitch the data together, and then they had separate tools for doing R training. And then with all the with the number of iterations, et cetera, when they had the models built, they would then send the model, R model, back to the development team. The development team used to sort of literally translate that model into Java code. So there was a loss of fidelity, there was a lot of turnaround time, and so overall there was a lot of pain. And by the time the conversion was done, the model didn't quite look like the way data scientists intended it to be. And this whole thing, sort of training, used to take multiple days, and the overall end-to-end process was months, literally. So from there, they moved to doing everything in database. So now data scientists were writing R code, that was embedded in T-SQL stored procedures running inside of the database. They didn't have to depend on anybody to put that model into operation. The other thing was they didn't have to depend on anybody to give them data. They were able to work on the entire data set that was available in the database. And they leveraged the scalable version of the algorithms, and they leveraged, in fact, they were able to achieve more performance because instead of working on their local laptops, they were harnessing the power of the SQL Server, which is usually higher than the laptop environment. So overall, they were able to sort of reduce the training time, the attribute selection and segmentation training time from over 2 days to less than an hour. And the overall sort of end-to-end process of taking the data, building the model, deploying it was reduced to a few days from months. So that's one example of how our customers are benefiting from doing in-database machine learning. Another customer, and by the way, these are all published stories that you can look at to get more details. Atom Data Solutions is another company that uses in-database R services to figure out what is the projected cost of properties as the time passes and based on the new data about property prices in the market. The other customer is
Probably I should get
the Axiom, which used to be a SaaS shop. A lot of analytics today is done using SaaS. How many of you use SaaS, by the way? Okay. So there is a trend of sort of, because of new talent coming up from colleges that are trained in SQL and Python, so there is a trend in the industry to slowly move from SaaS to R and Python. So this company used to do targeted marketing solutions and use machine learning for that. Now they moved from SaaS to in-database R. Similarly, there's Heartland Bank, a bank in New Zealand that did financial modeling, and they are now using SQL Server machine learning services as well. So enough talking. Let's actually see some code in action. See?
Just push the right button. This is going to be a very big data set scoring trainings example. But I don't know, for the data science in the audience, you'll probably know. Iris is a small data set. It's like 150 rows, but it's good to demo the thing. So that's what we're going to use. So I mean, just to give you an idea, I mean, if you have not played with R and SQL at all, so basically what we have is a stored procedure, which essentially takes a R code or Python. And I mean, I'm showing R here. The same thing will work with Python. And then some SQL parameters, right? So one of the fundamental things is like you need to be able to send data from a query to R, right? Because the data is in SQL Server. And then vice versa, like R or Python can do something with the data, transform it. So you need to be able to return some data back. Similarly, you have a bunch of parameters which you want to send to the script and then get some values back, right? So that's basically the high-level, interface available today. I mean, in the future, we are thinking of extending it to like probably like functions and stored procedures and so on, right? But this is what we have today. So this example, all it's going to do is it's going to send a row, this one here, and in the R, basically, I just add a column, right, which is passed from here, this parameter. That was a value like 2017, right?
So you see, those 2 lines is the R code, right?
Yep. These 2 lines here, it's in red. Well, this is also red, but literals, right? So I mean, right now you don't have syntax highlighting or coloring, for example, from SSMS. But if you were to develop this from R tools for Visual Studio, there is a way where you can develop it as an R script, and then you can say, hey, now put the thing as a stored procedure, and it will generate the SQL code for you. So that's pretty much what it did. So it basically sent a row to R. R did some computation and returned some results set back. In this case, like some additional column, right? That's pretty much it. Okay, so now let me go and create two tables. So one table is for holding the data. So the iris data set is about flowers. So for flowers, there is like sepal and petals. So it has like length and width. So based on that, basically you can predict the species, essentially, right? So that's the problem we are going to solve here, is like train a model which looks at the sepal length and petal length width, and then it says, okay, which species it is, right? So simple example, but yeah. Okay, so one of the way you can operationalize this whole process is like you create a stored procedure to do the training. So that's what you see here, right? So this one is using a RxD3 algorithm, which is part of the R package, which installs with SQL Server, and that's what we're going to use here.
So this is the Microsoft's proprietary R package that builds on top of open source that I was talking about.
Yeah.
All the functions prefixed with Rx belong to that package.
So this one right here, right? So anything which has Rx is what the Microsoft implementation, essentially. Okay, so this is really the line of code, right? So this basically takes the data. I'll just go here. This one here, which is name provided from the SQL stored procedure here. The data comes from this select statement here. And then this is what is called a formula in R, where the left-hand side is essentially the thing the model is going to train for, in this case, the species. And then the right side is all the attributes or columns it's going to look at, right? And then after that, you are going to serialize the model and then return it back to SQL Server as a blob. So in this case, it comes back as a var binary object, right? So that's what the stored procedure does. So that was the training, right? So now the same thing you can do for prediction, which is the reverse. So the model is stored in the database, you give the model and some new data. In this case, I'm going to just send the same data back. And then just like the RxD3, you have a Rx predict, which basically takes the training data and the model, and then it will predict the value, right? In this case, it's the species. So that's the procedure. So now just to actually show you guys, I am actually running this in SQL DB, right? So this is something we enable.
R is also
now.
running on Azure SQL database now.
So this is actually a big deal because this is first, I would say, in-database machine learning thing in the cloud, right? Fully managed. So you don't have to do anything. I mean, R is there. I mean, future we'll have Python also, so you can just run your code there.
So you see this is limited preview right now?
Yeah. Okay. So it's in public preview right now, so you can create servers in West Central US and you should be able to use it. And slowly over the next month, we'll basically enable in all regions, right? Okay, so now we'll quickly populate the data with that table with some data, right? So for that also, I'm going to just use R. So it's basically this line of code. So this data set is actually built into R. So we'll just use that. So it basically created that many rows. So you can see the data. So that's pretty much what it is. And then now you can train the model. So this is one of the things we are saying with the SQL integration is you can have your model management also in SQL Server, right? So you can basically version it, you can have history over it, you can find out like who created it and so on, right? So that's basically the training process at this point. And then now you can do the same prediction, which is, so this is going to give the species based on the model, and then what the model predicted and what is the actual, just to give an idea. Like the Setosa species is exactly the model predicted it very accurately. And then if you come down, you'll probably see some other rows where the model like it gives a probability value, right, from 0 to 1. So it said probably versicolor is also like around 90%, right? And then the other one is 92, so on and so on. So that's pretty much it.
So that was the hello world of machine learning with Iris example.
Shit, how do I go 4? Is it 4? Oops. No.
Yep.
Yep. Okay. Okay. Just to recap. So this is what. So 2016 was the big investment in terms of the extensibility framework, right? That basically laid the foundation for adding R and Python, right? And then R we added in 16 and 17. Like Python support is the big one, and then we also have native predict function. So this is something we'll show later. So this is basically ability to just write a SQL query to do the prediction. So you don't have to rely on R or Python, right? And then Azure SQL Database, that one is also, the predict function is available now. And then R support, like I said, it's a preview. So right now you can do in-memory training and scoring. And that's what you see there.
All right, so the way a lot of these things are working inside of the database is that we have a separate product, which is also sold as standalone server product called Microsoft R Server, that was integrated natively into SQL Server. So that's where it manifests as SQL Server R Services in 2016. In addition to running on SQL Server, it runs on multiple different platforms, on your Windows Server, on Linux box. It also runs on Azure, on HD Insight, on Hadoop clusters on-prem. So the idea is that you can do R-based compute and analytics wherever your data is. And the other benefit is that you train the model on one platform, and you can score it or put it in production for it to be operationalized in a totally different platform. And it works seamlessly because the underlying engine that is running is same. And it supports all those scalable versions of R and Python algorithms that I talked about. So we took R Server, and then with the Python support that we also saw in SQL Server, now we have rebranded that R Server product into something called Microsoft Machine Learning Server. We announced the GA of this today as well. So now Microsoft Machine Learning Server works and is natively integrated in SQL Server in the form of Microsoft ML services. So in addition to sort of operationalizing the models as T-SQL stored procedures, if you, for whatever reason, if you cannot leverage T-SQL way of operationalizing the model, you can also use Microsoft Machine Learning Server to operationalize your model as web services. So any application can then hook up to that web service and get prediction from that model. And in addition to that, recently what we have done is we have started adding some pre-trained models. As in, you don't have to build your own model for a lot of things that are like reinventing the wheel. For example, we have a image classifier that has been trained on a huge amount of data in Microsoft Research. So we have taken that model and we ship it as pre-trained model. So you can just reuse that model to generate features from images. Another such model is sentiment analysis from English language text. So you give it an English language text and it tells it's a positive sentiment or a negative sentiment. So we'll continue to do this. Thank you. One of the things that we have done with this release of Microsoft Machine Learning Server is that we have changed how people used to buy R Server for Hadoop. Now, you don't have to buy it as a separate product. If you have SQL software assurance, then for each core of SQL Server Enterprise Edition, you get the rights to run Machine Learning Server on 5 nodes of Hadoop. So it's basically a free entitlement for you now if you're a SQL Server customer. So that was about a little bit about Machine Learning Server. Now so Yushi showed you the sort of hello world example of machine learning, but with Microsoft R Server and the packages, custom packages that are built into it, we support some other scenarios. Before you put your R or Python code in SQL Server, data scientists work on small data sets. They iterate over things, and they like to work in their IDE and their environment, be it RStudio, be it PyCharm, whatever. But there are limitations right now that you have to move data to your box in order for you to do machine learning on full-scale data. So with SQL Server Machine Learning Services, what you can do is you can connect to SQL Server, and with a concept called remote compute context. So we have APIs that allow you to do that. I'll show an example in a bit. And right from your data science IDE, data science environment, be it Jupyter notebooks or whatever, you're connecting to SQL Server, and your actual code execution for R and Python is happening in the SQL Server box. And you are getting the results back in your IDE. So you feel you are continuing to be productive in your IDE, and you are able to now work on the entire data set, and you're getting the results back and so on. And when you're done with that, and when you're happy to, you're happy with the quality of the model, you can then put it in production, like embedded R or Python code that you showed. And then it's extremely simple for applications to consume the model, consume the intelligence from that model by just making a simple stored procedure call. So they need not even be aware that there is something called a model. They're just making a connection to a database, making a call to a stored procedure that they always do. And since the intelligence is now built into the database, they're getting that smarts, and their application is getting smarter. So what this helps with is your existing apps can now suddenly start to leverage. You don't have to change any code in your existing apps, and you can suddenly take advantage of the new models. And as the models iterate, as the data scientists work on more data and improve the models, and then your application automatically gets the smarts from the improved model. You don't have to make any code changes, right? So let's dive a little bit deeper into a more realistic example. We'll together show a demo where the scenario is that an ISV is making an application for hospitals. So unlike hotels, when we checked in our hotels yesterday, day before, we told them exactly how long are we going to stay. Hospitals, when you're getting admitted, we don't know how long we are going to stay. So it brings a lot of challenges for them, hospitals, to figure out how to allocate the right resources, how to allocate the right staff to ensure appropriate resource utilization, as well as appropriate outcome for patients. So if they were able to predict the length of stay for patients based on their historical data, based on other factors, then they can make some smarter resource optimization and staff allocation decisions. So I'm going to walk you through those two things that I showed before. Right? So I will do the data scientist part, where I'm building the model in my IDE, connecting to SQL Server, and then UC will show you the SQL Server side of things.
Switch, right?
Yeah, 6. So before that, so now with the, let's say with the predictions available, I can do dashboards like this. So let's say I am a line manager for a particular department, and I want to see how many people are getting discharged 6 days from now. So I see that on Saturday, there are quite a few patients getting discharged, so I better staff up my discharge nurses on that day. Similarly, on a larger scale, if I am the chief medical officer of the hospital, I can then make decisions about sort of moving resources from one department to the other and so on, right? So you understand get the idea of the value of this kind of predictive model. So now, this is my IDE of choice. I'm the data scientist working with Python code in Visual Studio Code. And this is one of the proprietary Microsoft packages called RevoScale Pi. This is the package that has the scalable versions of algorithms and APIs for doing things like remote compute context, connecting to different data sources, pulling and being able to work on that and so on. So I'm importing using that package, and I'm establishing connection with the SQL Server with this connection string. And I'm doing some basic data split and so on for training and evaluation set. I'll not spend too much time on that. Let me take you to the part where, now here, I've done all of that. And in this line, by using the RX compute context and the RX set compute context function in Python, I'm able to say now, from now on, whatever code I'm running, run it not here, but run it on the SQL Server box on the data set that is there, right? So here I'm now training the random forest model, giving it the appropriate parameters that is needed. And then similarly, I'm doing another B-tree model training, and again, I'm setting the compute context to SQL. And then I do, come on. Sorry, the connection is a little jumpy. And then based on the two models that I have trained, I am doing some model evaluation, calculating things like root mean square error, et cetera, to determine which of these two models I want to put in production. And when I'm done with all of that, So I'm then what is that? I'm making some predictions and I'm testing the efficiency of the model, and I'm able to write that model into SQL Server by using the RX. What is the right code? My thing is jumping. Anyway, so right from this IDE, I can write into SQL Server, and the model gets written as binary blob of data in SQL Server table. So let's see what happens on the SQL Server side.
Sure. It's 8, I think. Okay.
Yep.
So here, basically, I have a database which has the same set of data, right? So one of the things I think we're actually saying with the ML services integration is you can do many of the transformations and feature extraction and other things in SQL Server itself, right? So if you look at some of the improvements made in column store index processing today in SQL Server, so we can actually even push down predicates all the way to the scan. So it has like tremendous performance benefits. So what we have here is typically, I mean, like if you see some Python code or R code, I mean, they would actually compute some of this in the Python code itself. But now, since you have a database with a rich SQL interface, you can compute a lot of the aggregations in SQL Server, right? So that's what we have here.
So you see, that's another big point about this integration, right? So you have the best of SQL Server and the Python and R languages to do the right things and using the right tool. So you don't have to do data preparation in Python and R. You can leverage SQL for that.
Yeah. So the key assumption is the curated data is in SQL, right? And or it's coming from other sources, but you're getting it through SQL Server. Okay. So this view has basically it accesses a table, this training sample, and then it's basically computing a whole bunch of parameters here, right, to the Python script. So some of these are some deficiency that the patient has, right, and some are like sodium, like how much based on their measurement, right. When they get admitted, you'll take like a whole bunch of measurements. So that's the information. And then it's basically has other input like how many number of issues they have and so on, right? So same thing, we have a reverse here, which is basically so the training sample, but with a different data set. So one of the things with the machine learning process is generally you would do some sample of data for training, and then you'd use another sample to do the testing, and then you would compare the results, right? Okay, is it working fine? And then you might tune your R or Python script so that the model actually is doing a good job of predicting the outcome, right? So in this case, it's how long the patient is going to stay, right? But this is basically on historic data, right? So there is already data in the database, right? So for example, if we come to the end, I mean, this is some historical data which you got from some patient's information, and you already have it, right? So that's what you're going to use to train the model, right? So same thing with the scoring, right? We'll have a reverse. So now let me go to the procedure here, which. So we saw the Python code a bit back, right? So we have the same piece of Python code here. Some of the information, like it will come from SQL Server, obviously. Even here in the database, you can do the same compute context, right? So this has some advantages in terms of being able to leverage parallelism and so on. So we have a session later on Thursday where we'll touch on some of these aspects, like how does a parallel query and parallel execution of R and Python works, right? So this is pretty much the same piece of code, and you're doing the same thing here, this RX deforest. And just like in R, you have the same formula concept, like the left-hand side is the attribute which the model is going to learn about. So in this case, the history information, right, as to how long a patient stayed. And then the right side is all the attributes which you want the model to look at so that it can find out like, okay, based on that, what resulted in this patient being in that room for like a week or, I don't know, 4 days, whatever it is, right? So that's what it's going to do. So, and at the end, the same thing. I mean, you can use some function to serialize the model into like a memory as a binary object and then send it back to SQL Server. So in this case, I'm using like Pickle, which is a library in Python.
There are also RX write object function that
which you can use to write. Yeah.
You don't have to use that.
So now just like the same example, I mean, you store the model in SQL Server at the end, right? So let's quickly run this. So this one is actually going to run with 4 BOP, so on my machine. So you'd come down here, you'd probably see all of these Python processes, right, running. Suddenly you saw like some 4 got increased, right? Before you saw like only 4 or 5 running there. It takes about 11 seconds to run, 20 seconds, okay, so now it's done. So that actually trained the model, right? So you could actually go look here. So in this sample, I have both R and Python, but I'm not going to run the R code. So that was the training process. So in the hospital case, I mean, they would probably run this like periodically, right? Like it depends on how often they want to give new data to the model. So they would schedule it as a job in SQL Server, the stored procedure. And as the new training data comes, I mean, it will go refresh the model, right? And then it gets stored in the database. And then now we look at the prediction part, right? So same thing, once it's in the database, now the dashboard, I mean, there was also a website which we have for the patient data, right, which you showed some time back. So there, the same thing. So you basically have some patient who's been admitted now. I mean, he got some accident or something. And then you come and click there and say, okay, admit this patient. And at that point, you give all these metrics to this stored procedure. And then it's going to spit out a row saying, okay, this is how long we predict this patient is going to stay. And then depending on the availability of the rooms in the hospital, they will put them in the right room. Right? So that's the scenario. So same thing here, so it's a reverse. So it's the same piece of code which you saw there with the RX functions. And then you would first load the model. Same thing, I did the pickle with the dump s. So now you do the loads, which does the reverse, right? And then same, you will call the RX predict now. So this now gives the new data, and then you get the result back, right? So that's the scenario. So let's come here and run this one. So it's going to run on some sample data set, right? So it's about 1,000 rows. It's sent to the model, I mean, to the Python code. And then you can go look at the predictions, right? So this is how you would test. Like, so for example, if you take this first row, this is historical data, right? So it predict the actual stay was about 4 days. The model predicts about 4.48, right? Like close enough. So some you'll find like it's predicting more or less, but that's the nature of the data science process, right? I mean, if everything is accurate, then I mean it's not really good. So that's the data set which you saw. Okay, so now I talked about the website. So now here is a version which basically does the same thing, except like you can see, right? It's going to take all the new patient's information. So
should I show the website quickly?
Yeah, we can go back.
Let me do that.
Yeah, let's going to bring it up.
Yeah. So
Yeah.
imagine I am a intake nurse in emergency department of an hospital, and I'm looking at the queue of patients who have gone through the triage process and need to be admitted. And I look at the queue, the first person on the top of the queue is Anthony, and I look at what the doctor has ordered for this patient, and as soon as I hit admit button, instantaneously I get this forecast now. So I can then, as this nurse, make the decision about which ward to assign, which staff to assign this person for, right? So that's the power of sort of instantaneous real-time scoring that he'll show more in the code.
So yeah, just to, yeah. Okay, so now imagine that web service is actually calling the stored procedure, right? I mean, so it has the information about the patient, right? Whole bunch of parameters, which are all the measurements which we originally used to train the model, right? So in this case, it just happens to be one single patient. And then, So here is where the SQL part comes is like, first of all, some of the statistics information we use for the training, we need to use the same information. So now we get that also from the query, right? So this query is actually looking at the training data, but it's computing all these statistics, right? I mean, this could be a real big data set too. I mean, it's on a column store index, so it will be extremely fast. And then you do the same computation. In this case, like you can see here, like it's doing all these subtraction of the average and using the standard deviation to normalize the values. And then it also computes like how many issues he has, like this one particular patient. And then the main thing which we are calling here is now this new table valued function called predict, right? So this is basically a SQL function. At this point, there's no R or Python. In fact, I can run this piece on code in Linux, SQL on Linux also, right? So there is no R Python involved. So we took the R server, ML server scoring piece, put it in SQL Server natively, right? So that's it. So it's just a SQL function. So it'll be extremely fast, like you would anywhere get from few milliseconds latency, right? That's
No, the database can do this fast scoring of predictive models. Be it on Linux, be it on cloud, you're the fastest.
So I just called the thing like an example to, create a patient, and you could see the row here, right? This guy here, right? And at the end, you would see, okay, for this one, it predicted like 4 or something, right? So that's the scenario here. So it's just, so the predict is basically targeting scenarios where as the new data is coming into the database, you're inserting as your OLTP transaction, whatever it is, you can simply call a SQL function to get some predictions, right? So that's the way to kind of operationalize this whole machine learning thing. Oops, let me go back to the deck. Oh yeah, there you go. Okay, so you saw that example. So patients, obviously, you're not going to get like millions of patients getting admitted in the hospital at the same time. It should be a bad scenario. But yeah, so the other scenario is fraud detection. So this is something which we've seen some of the customers do. And so here is a scenario where you might get like thousands of transactions in the same instance, right? And you want to be able to basically assign like a risk or a potential of fraud for the transactions as they are being inserted, right? So this is another scenario where like the prediction in the database helps, right? So in this example also same thing, like as a transaction is happening, you also want to compute like some information, right? Like last 30 days, how many purchases did the user make, right? Like, I mean, did he do like only one purchase or hundreds of purchases? And what were the amounts and so on, right? So this is something you have to compute in the database, right? Because you have to go look at history, right? So it's like I go to buy something and you have to look at history 1 month back or 2 months back, right? So this here we have a scenario where the model will use all of this information. And at the time of prediction, you want to be able to use the same information, right? And then to do the prediction. So let's quickly look at this example.
So this is one of the scenarios where real-time yes and request response type scenario is very important, and that's where native scoring shines.
Yeah. So because like, I mean, you don't want to say like, hey, wait for 5-10 seconds and then I'll tell you if it's a fraud or not.
Why don't you batch all your fraudulent transactions and I'll give you a transaction after it has happened? Won't work.
So here, this is basically targeting that one, right? So this is how the view kind of looks. I mean, I have a database here with some sample transactions, credit card transactions. And credit card transactions can originate from different, places and so on. So obviously there's a join to like a country table, for example. Sometimes the transaction can be an online one or an offline one. So if it is an online one, you want to probably find out what browsers they're using. Sometimes some of the fraudulent transactions might be from some scripted code, right, which is actually pretending that it's a browser or something. And the user agent can give some information about that, right? Similarly, some states, like where they originated and so on, right? So this is a typical, like a star schema, right, in a data warehouse. So that's kind of the join you see here. So you can quickly look at the data here, right? So it's, yeah, so you have the amount, some code, what time it happened. And then as part of the training, I mean, I won't get into the details of it, there is some risk values which are generated and assigned to each one of these attributes. And those are the values which you see here, right? And in this case also, the training will use the boosted trees function in the Microsoft R server. So that's the thing which you're seeing here. So this is pretty much the line of code, right? Take some new data, and then it basically figures out which one is a fraud or not, right? And we'll give some input to this guy. So let's train the model. Takes about 20 seconds here. And then you can look at the model just like how you would do.
So I guess you're seeing the pattern. Embedded Python and
Yep.
R code, running in database.
So this is our code, yeah. Okay, so it's done. Same thing, right? So now I stored the model. In this case, the model is actually pretty big, right? It's about 127 KB. So now, once the model is there, you could do scoring either way, right? First, I'm just going to show like the R code just to give you an idea how you would do it from R. So this is how it would look, right? Same thing. There's always one predict function. That's it, right? It takes different models and it can predict the information. So this is how you would implement it if you were to call into R, right? But just for fun, we'll just run this also. So I'll run it for about, I don't know, 1,000 rows, right? So this thing is actually going to start R on my machine and start it, right? I mean, even this was like pretty fast, like about a second, right? So now I have the same thing implemented here as a native scoring one. So which is, imagine that an insert happens. In this case, I'm just inserting just the score and the transaction key. But these are the piece of SQL code here, right? So let's run this. Yeah, so that's how fast it is, right? So it's about like milliseconds. And then as I reduce the number of rows, that's where the difference is, right? So if you're doing like per row, for example, right? So this is about 47 milliseconds. But, I mean, it's not just doing the predict cost, right? I mean, it's doing a complex SQL query. I mean, it's doing all of these, right?
In few milliseconds.
Yeah. So it's doing all the SQL part, and then it's also doing the scoring part. So that's where the power comes, right? So the other one is also works almost the same, except, I mean, it has to call into R every time, right? So that's the overhead which you would always see. I mean, there are reasons why that other one also exists, because it's I mean, more general purpose. I mean, you can leverage other open source, libraries and packages if you want, right? But this is, I mean, it's still not bad, right? Like about a second on my laptop, right?
So the idea is that one way of doing Rx predict, you can use whatever R code, Python code that you need to use. But if you really want that millisecond order of performance, then you can use a small set of algorithms, the Rx algorithms, and use native scoring for that kind of turnaround time.
Yeah. So low latency, high concurrency environment. So this is what you would use. I think that's pretty much what I had to show. I mean, later on Thursday, we have a session where we'll cover more in detail about all of these performance aspects, right? Yeah.
So sort of let's recap, right? With in-database machine learning, what you're getting the ability to do is you are doing your data science development the way you always do in your IDE. Now you have access to fuller data, bigger data set, and you have the ability to run your machine learning code while at the time of development in SQL Server on the entire data set, right from your IDE, right? And then operationalizing that model or putting it in production is very simple now. You just embed that code into T-SQL stored procedure, and the applications become smarter by calling into that stored procedure. And so that's the overall sort of pipeline. And it makes sort of both development as well as operationalization of machine learning much, much simpler, secure, and enterprise grade. So looking forward.
Oh yeah.
Azure, yeah, go ahead.
This is the roadmap for us, like basically, I mean, we have like 2 slides on this. So Azure SQL Database, I mean, one of the things we are working on is like getting some of the configuration and monitoring pieces for R and Python. Because on the box, like you could go to Windows perf counters and go look at what your R scripts are doing, what your SQL scripts are doing. So that's something we are working on in the future. And then Microsoft ML package is the other package. I mean, we didn't show but we showed the RevoScalar one. But that's the other package, machine learning package, which is not yet available in SQL DB. But that's something we're planning to light up.
So this package has some of the state-of-the-art machine learning algorithms that Microsoft has used in products like Bing and Xbox Live, etc. Internally. And now we have basically packaged those algorithms with Python and R bindings in Microsoft Machine Learning Server and RevoScale Pi and Microsoft ML package. So that's available to you.
Yeah. And then the other piece is what we call in-database package management, right? So since SQL DB is a managed instance, I mean, you can't really go to the machine, remote desktop, and install your packages, right? So we need a mechanism where you can upload your packages into the database. So this actually exists in 2017 today, where we added a new DDL in SQL Server, just like create assembly. We now have a create external library, which allows you to upload a package as a payload, right, into the database. It's basically a zip file for Windows. And then the engine will automatically provision it on the disk or before the R script executes. So that's the other mechanism which will be available in SQL DB. So that way you would at some point go to your R script and do an install from there, and we'll automatically put it in the SQL database. So this is actually a big deal because, I mean, obviously we don't want you to just use, I mean, like just these 2 packages may not work for all of your scenarios, right? You might want to use Prophet or like, I don't know, Carrot or any of these packages, right, open source packages. So that's the idea behind that one. And then the other one is the SQL compute context support, which you saw. Right now it's not possible to do that. So that's basically from your IDE being able to point to your SQL DB and say, okay, run my R script or Python script there, right?
So basically, Azure SQL Database, we have just started. This is preview. We have a way to go, and a lot of these things are coming. It will be at parity with on-prem SQL Server.
Mm-hmm. Yeah, and then the parallel execution for the scripts, so that's the other piece, which I didn't show, like to be able to train in parallel, right? So that's the other piece. And then future, the things we are working on is machine learning services on Linux. I mean, on Windows, we did a lot of investment in, which I didn't touch on, like in terms of security, resource governance, being able to give different resources for R and Python versus SQL Server. So that's something we are working on Linux, right? So if you're interested, feel free to reach out to us. And then the other piece is failover cluster support. So this is basically a shared disk cluster architecture for SQL Server. So we have a lot of customers running their big multi-terabyte data warehouses on a failover cluster, and they want to be able to run R scripts and Python scripts on the DW instance. So that's something we're working on. And then the other thing is what we call like a partitioning support. So this is also very common. Like you saw the hospital scenario, right? One of the customers like is doing similar thing, like where they have a model per region, right? And they want to be able to build that model per region, different models. So that is the ability. So you have an input query where you can say, hey, this data is partitioned by region, and go run the R script or Python script for each partition, and then return the data. Right?
By the way, I think I missed talking about that when I was talking about ML Server. There's something that we released recently called RxExec which allows you to do partition from your R environment today. So it's already supported.
Yeah, so that's what you would leverage at some point, right? And then the native scoring, that's the other thing we're looking at, is like more models, right? Some of the Microsoft ML models are not available there today, and that's something we are planning to expose. And then the other thing we're looking at is how can third parties use the same extensibility framework in SQL Server, right? Like for example, if your dev team is interested in, I don't know, Scala, right? You want to use Scala with SQL Server, and you want to write your own SDK and run it with SQL Server, right? Through the same infrastructure, right? So that's something we're looking at. So that's pretty much just to give you an idea of what we have. And then,
and we have a bunch of resources here that you should take a look at, and a bunch of samples on both R services as well as Python machine learning services one. UC has built a bunch of SSMS reports that would be useful. Other getting started and other tutorials, and those are all useful. And there's another session on Thursday, as you
Yeah,
just
like
mentioned. that you should
performance
confirm.
patterns, like this, so where we'll talk more into like how some of these things run in SQL Server, how fast can you scale the machine. I mean, we'll show some demos which are more geared towards performance. And I think the getting started tutorials is the best place for you to, I mean, if you don't know about this, like you just want to try it out, right? That's a place.
So I think that's the end of it. Please give your feedback to us.
Oh yeah, go back to
And sorry, what is that?
Can you go back to the previous
Oh,
slide?
okay,
I
resources.
think people to see.
Oh, okay.
resources.
Sorry.
Yeah, the URLs are straightforward. The SQL Server developer tutorials, I don't know if you've seen. I mean, that's actually the place where we have the development tutorials, and then similarly we have the ML equivalent also. I think we're done with this. Actually, we're
All right.
pretty much done.
Thank you so much. And we are
Questions?
open for questions if you have any.
Everybody understood everything. Yeah.
Yeah, please come on over here. If you can come to the mic.
Mic will
or,
be
Or
good.
go ahead.
So my question is, we have a lot of R scripts that do web scraping, and we do use 2016. So one of the challenges that I have is using the R scripts that do web scraping, which basically access the internet and different websites and grab documents and stuff like that, etc. They don't work within stored procedures. So something that I might be missing, or you don't support it.
Yeah, so one of the security principles we had is like with R and Python, I mean, people can go like install anything random on the SQL box, right? So by default, we have firewall rules which essentially block all outbound network access from any R Python scripts by default. So, I mean, I can show you how to open some of the holes for it, but that's something you'll have to configure on your end, right? So out of the box, if Windows Firewall is enabled, those are all blocked.
And that is by design.
Yeah.
We've secured data. SQL Server is meant for critical business needs, and we want it to be very, very secure.
Yeah.
And so that's why we have by design.
But
done
it
that.
is possible. By
Oh yeah, it's
It is
possible. Yeah,
possible,
you can,
but we should
yeah.
talk offline to see understand why you have to do that in SQL.
And is this ML services coming to 16, or is it just in 17?
By that you mean the Python support coming to
Yeah.
2016?
Yeah.
At this point, we don't have fixed plans, but it is possible.
Hi. So basically, I love the idea of integrate the R script or Python into the SQL so that you do not need to deploy one extra Azure VM to run the R script. But based on my experience, so when we do the data analysis, most often our data source is not a SQL. It's like Cosmos or Hadoop or other like unstructured data source. So do we have like the interface to load data from other resources?
Yeah, so today SQL Server has Polybase, which can actually talk to Hadoop. So one of the ways customers use SQL is to define what is called external tables in SQL Server, which basically point to Hadoop clusters. We don't have support for HD Insight because HD Insight doesn't use some open standard API right now. So, but that's something we're working on. Like, how do you point SQL Server to HD Insight?
So,
But there are connectors available. That's how you get to data from some other place and basically use it from SQL.
and so the overall idea of sort of the underlying ML server working in SQL Server is you should be able to do machine learning wherever your data is. If your data happens to be in SQL, then you can use it natively, and there are a lot of other improvements that we have done. But if your data is not in SQL Server, you have other options. You can run ML Server as a standalone thing and get data from whatever data sources you have. And if your data is on HD Insight, for example, it runs there.
Yeah, my raw data is not in SQL, but I wish after the process data, I wish to put it into SQL so that I can leverage the Power BI, you know,
Yeah.
I see.
for the visualization. Yeah.
Got
Yeah.
it, got it.
Yeah.
So
Well,
aggregated-
Polybase is the way to go.
Yeah,
Yeah.
Okay, and another question is regarding like, I saw we can run the R script directly in the SQL environment. So do we have a good experience regarding how to debug those R scripts?
Yeah. Oh yeah, debug. Yeah. So this is something we recommend you don't do from SSMS itself, right? Because you're not going to get the command completion, code completion, the interactive window for R and all that. So you typically start from the R side where like we showed the RID, right? It can be RStudio, it can be RTVS. And then you would use the RX functions and
Okay, so
those things to
basically
interact.
you debug it in the RStudio and then move it to
Yeah,
run
and then
in
move,
SQL.
yeah, debug it, move it from there. And like I told you, like our Visual Studio has a way to actually create like stored procedure based on R code. And
So-
that's the other way to do it.
So that was the part that I forgot to show. The idea of doing remote compute context is that you should be able to do the debugging and everything. You nail down your model and R code in the IDE itself. This is where I was just running the R
VS Code, yeah.
VS Code, right? In your IDE, whatever your IDE of choice is. And you've done all the debugging and everything. You've taken care of it. And you're ready to sort of operationalize this. And then you put it in TC. So you don't do
Thank you.
development there. Okay, thank you.
Hello. One other thing I was thinking about her questions to have unstructured data to SQL. We use what we call the Azure Data Factory. I think you can take unstructured data and push it as a source and then push it to SQL if that would help. My question is, this is a great tool. How do you guys have some type of, I know Azure has pricing to know what you're going to use, how much it's going to cost you. But do you guys have something that can, based on the computation, to predict how much money we're going to get charged if we use, you know,
You can build a
Azure
model.
itself?
You can build a model based on historical billing data, I guess, and say. But that's something we are looking at more closely.
This is an excellent question. So, no, we don't. But this is, we've talked about it internally. Like one of the interns came up with this idea of sort of doing, especially on our server running on HD Insight and on potentially our services running on Azure SQL database, where based on your historical trends, we could say your consumption forecast. What your consumption will be like, but no, we don't have that right now.
So, by the way, that's
great
$1 million
question.
idea I just gave you. Anyway, so I see that because I'm not an R or Python developer, I'm a C# developer. So the way I'm seeing this is a way you can actually use that data, put it in SQL, and actually use stored procedure to do REST API and put it in, I don't know, in a visualized jQuery type of application. And then that way it's used. But it's only 2017, you're saying, right?
No,
it's not like...
no. 2016 has R support.
Okay.
2017 has Python support on top of R. So that is the new addition.
So the 2017, you don't need to know R, you just need to know the syntax for the RX, B-trees, RX this, RX that, right? That's what you need to know to write the SQL Server. Is that my understanding?
No. So the RX predictor is just one example of a function available in what is called the RevoScale-R package or the RevoScale-Py package, right? It's just some R code, right? Similarly, there is a Python version of it, right? So Python and R is there in 2017 support. You can use any R or Python code. 2016, you can write R code. So that's pretty much it. Like that is the difference.
I think there are a lot of concepts here, right? One is you have your R code that you are running near the data, embedded as R code running in T-SQL. That's one part of it. Now, but if as C# developer, as an application developer, if you want to access that model, you don't necessarily have to do that. Somebody else has built that model and put that code in there.
Okay.
Let me actually switch to show you how that web app that I showed you, how that works. So if you look at this is the simple JavaScript code, as just like regular web app, right? And all that it is doing is, it's making a call to this one stored procedure. So that is what I was saying, that one line call to a stored procedure gives you the intelligence from that model. This application developer didn't have to even know that there was a model running in there. It could have been just any other regular stored procedure. So that's the powerful, very powerful thing, right?
Nice.
And it's sort of other angle that we didn't stress that we should have is it makes collaboration between data scientists and developers and data engineers so much simpler. I actually talked about it when I gave the pros example. So that's a powerful thing with this integration.
Okay. Other than that, good
Thank
stuff.
you.
Hi. Sorry. Hi. I have two minor questions really. One is for our studio right now. We are dabbling in with it, me and the other database administrator for a small healthcare company on the East Coast, with doing some predictive analytics in R. One of the major things we're struggling with is there any good way to basically, if you have a predictive model and you're doing something like ggplot2 in RStudio, to basically embed, your return plot into like an SSRS report so that it just automatically refreshes as data comes in.
Yeah.
I mean, we've come up with some strange workarounds where we save the file as the same thing to a place and then we have a stored procedure that pulls it in. But we haven't come up with anything that's really that great of a solution.
We do. UC is going to show you
Yeah,
in a
that's
second.
very easy to do.
Hold on, what's the,
I mean, I think I have an example with ggplot, maybe.
what's your number again?
8. So, I mean, you can write to a file and then get the data through that. So let's look at, where is that?
UC, why don't we, can you stay a little bit after the session? Yeah, why don't we show the code to him offline?
It's here.
My
I have a SSMS report which actually has that.
Yeah,
but
yeah.
Yeah, I'll show you the thing.
And my second question has to do with, you said that in the latest edition there's a built-in model for basically natural language so that you can you use that to clean basically free-form text fields? Could you feed it free-form text fields and it like corrects misspellings and just poor data? We have a lot of free-form fields from an old mainframe system. We do a lot of cleaning with it. Is there any way we could hook it up and basically clean the data so that it's more understandable?
So
We've used data services, but it ends up being too much management because you're constantly
Right.
putting new findings into it.
And so there is a sort of transform pipeline that is part of those APIs, those algorithms, where you can do some amount of sort of data cleaning, stemming and removing the stop words, etc. But then the actual quality of the model output will be dependent on the quality of the data that's
Input.
going in.
Bad data in, bad data
So there is a pre-built model. It understands sentiments for English language text. But then if your data is too much garbage, very different from the data that it was used to train for, the results, your mileage will vary.
Yeah, okay. Thank you.
Oh yeah, so this is a piece of code, right? So this is actually using ggplot2, and then I use qplot here. So the way to do it is like you create a temp file, and then set the context to that. In this case, I want to write a JPEG file to it, and then you can just print to that. And then once you're done, you basically read it here, like read bin as a binary blob, and then send it to SQL Server. So that's how.
Okay, that's basically what we've been doing. The only
Yeah.
difference is we haven't been reading it into a binary blob. We've basically been saving it, and we have a stored proc that goes and pulls it every time you refresh the SSR.
Yeah, instead we actually send it to the database itself, and then you can store it in the database if you want. In this case, I was just plotting here. So I was actually playing with the code where I was trying to serialize in memory and then send it to. So I think it's possible. I think with Python it's easier.
If you stick around,
Yeah.
it might
With
be.
R,
Okay.
it is,
Yeah.
I think you are.
There's a question over there.
The question I have here is when you speak about Polybase connecting to the Hadoop, what kind of security you are using? Like what kind of authentication we should use?
So right now we don't. I think there is like we have RPC support. Like there is one for RPC security, and then there were few other things we support. But some of the security things we are not yet supporting. That's something we are actually working
So
on.
do you support Kerberos authentication or not?
No, not for all the vendors, I believe.
Okay.
Because each one of them have like some different frameworks depending on who SQL
Yeah,
talks to.
yeah,
So we are actually working on with some of the vendors to integrate better.
Okay.
So that's something we are working on.
So right now it's not in
Yeah,
place.
if you have specific examples, we can chat. Yeah, you can
Okay.
offline.
Okay. Yeah, I'll maybe email
Yeah,
you or
just
something
send me,
like
yeah,
that.
it's-
Okay,
yeah.
sounds good. Thank you.
Thank you. Question over there?
So this is fantastic. So we are a BizSpark Plus company and we build products on SQL Server. So one of the things we are trying to put specialized forecasting and supply chain solutions on the warehouse itself, where the data resides, right? Rather to move it to a separate, tool as such. So far we are limited to using SQL 2016 and also we have to commit to the number of cores and those kind of things, right? Now when you have it in the Azure SQL, right? Is it something we can do an on-demand scaling? For example, at the time of training, we scale it up,
Yep.
right? And then scale it down. And
Yeah,
it will exploit that many parallel cores to speed it up. Okay. My next question is, how do you use something like TensorFlow, which now has Python libraries as well?
Okay.
Is it an external context only, or is something?
So to sort of add to your first one, right? Yes, we are adding our support in Azure SQL Database. It's in preview. We are going to build it. But today, for example, you can spin up Azure SQL VMs. Is that an option?
No, but see, if you're selling it to a customer, they need to commit to the number of cores
see.
they're going
Yeah.
to buy from a licensing point of view. But when you're doing Azure SQL,
Yeah,
you don't have to do it
Yeah,
because
you
all
are,
consumption.
no, so you can scale. So there is no. So today, the way you would do it is you either go to the portal and change your service tier to say P1 to P11 or something.
Right.
Same thing you can do here. So if you're running your database normally as a P2 or P4, you would run it. And then during the training process, just before that, you can change your edition to P11. So that will give more resources to R and more resources to SQL Server, more CPUs and so on. And then once the training is done, you can change the edition back and you can downsize.
But if you could do it in Azure SQL, it's something like you increase the DTUs. Like I use Azure SQL
Yeah,
DW.
I'm talking about Azure
And
SQL,
in
yeah.
DW, it's very helpful. If I have
Yeah.
workload, I increase it and I reduce it.
So it's
right?
not on DW yet, by the way. Just
No, but this you can do with SQL DB too. The way you do it is you change the service performance level,
Okay.
service level objective.
Okay.
That's what it does.
And it will exploit that many cores for the training
Yeah.
part, and then I can scale it back.
It's the same like there you have the DW DTUs, right? So same here you have DTUs.
Right.
So you can do that, and then it will change the database to that, and then you train.
Which we couldn't do in SQL 2016, of course. So that's the opportunity here.
Well, yeah, 2016 is an on-prem thing, right? There you have to control everything, but Azure
Right.
SQL DB is a fully managed thing. So there you have the same
Exactly.
ability.
Exactly. That's why it makes things more flexible for us.
So now your TensorFlow question. So with Python integration, what we have is a subset of Anaconda packages that are installed for you automatically.
Okay.
Now, TensorFlow is not included. We also have to think about sort of the size of the overall installer, etc. But like I said, there is full support for any external AI framework. So you can, as simple as just doing pip install TensorFlow, and you can, in the right path where the SQL Python services are running, and immediately you can install it there. So you can bring any, use Conda installer or pip installer, and you can get it, and it'll just work.
So there are two aspects of it, right? There is the training part and then the inference part of it, right? So training, I can even use some external Python server or whatever that we spoke about, right? Which could be scaled. Now, what about the inference part? Would that slow down things, or do you think?
So, so far as the ML services and SQL Server is concerned, we don't really make that much distinction in scoring and training part. It's all Python code running in database, right? So, other than the native scoring part where it's a separate thing, right? But for general Python purposes, right, you either have the training code or you have the scoring code. All of that is running inside of SQL Server. So what happens is, the SP execute external script, the new system stored procedure that you're seeing here on screen right now, when the execution comes to that, SQL engine passes the compute to Python or R runtime, which is running on the same box. And that runtime is now capable of sort of doing all sorts of general purpose Python computing for you.
So whether it is training or inference, it's going to that context.
Right.
Yeah, it
even,
doesn't
even for the
matter,
scoring part.
Unless you use the predict thing, where then it doesn't go to the R or Python runtime.
Then it's SQL.
So now, assume you are using a TensorFlow and you want to leverage GPUs and your SQL happens to be running on a GPU box, it'll automatically run that and you'll get the performance benefit from that. I have a demo where I show GPU-based deep learning running on SQL Server. I can show you afterwards.
I mean, I personally like this even better than Azure ML because the kind of completeness it gives me and the solution we can build.
Right.
We don't have to include any other services.
Yeah, and also you don't have to move data. I think that is the big piece.
And it seamlessly integrates with the application. I mean, my app
Yeah.
is using
Yeah,
SQL Server, then
exactly.
everything is in there.
I think there's another question in the back. Yeah.
I actually have a couple of questions. So we've been trying to do a lot of AI-related work, and we've been looking at a lot of different companies that do this. So some of the things I want to ask you is in relationship to what we see in the other offerings. Usually the prediction servers are separate from your modeling or training servers. So with this particular solutioning, it's going to be one. I want to confirm that assumption. It's not.
No, it's not, yeah.
Okay.
It's not
I mean,
going.
it doesn't have to be, right? Like, so for example, we have customers who are running training on their always-on secondaries, for example. Right?
Running training on
So SQL Server has a cluster configuration, always on, which
Yes.
basically allows you to, it's a shared nothing thing. So you have different servers and each one can basically do a different role, right?
Sure.
So you could run your training on the secondary, which is getting your reporting workload or read-only workload, and then do the prediction on the thing. And the other ways, you can actually do a training on your data warehouse server. And we showed examples where you can store the model in SQL Server, right? So then you copy the model or you write the model to your OLTP thing, and that's it, right?
Okay, so you do the training on like our DR.
Yeah,
we need to.
different place or like in a DW instance, and then you could copy the model and put in your OLTP servers.
So not only can you do it on different SQL Server boxes, you can do it on a totally different environment. You can do it on HT inside running our server, and you take that model and you write into SQL Server, and it'll still work. Again, underlying
The
ML
columns
services
has to
concept.
match and all that.
Sure,
Right?
sure.
The assumption is that the data that is being scored has the same schema that was used for training.
Absolutely.
So as long as that is satisfied, it's agnostic.
Yeah.
Sure. Second question is around the training itself. So, you know, we train on all of our historical data. How about the deltas for that particular day? Do you have an approach or recommendation on that? So, like, we do a lot of fraud detection. And sometimes, you know, it's just during that day that the fraud could start to happen on a certain shipping address, for example. So do we train the entire model again, or how do we bring that delta in most effectively? So I may have like all of data, like typically, you know, my model will run once a day at night, and I have all of my historical data incorporated, but then the activity that happened during the same day, so if I'm at 4 p.m., my activity that happened earlier in the day, what's the best way to incorporate that?
You should, the real data scientists who deal with this might have a better solution for you. But what you're saying is, how do I sort of retrain the model on the fresh data that came up, right? So you can run the training script that is embedded on the new data that came on that day, or you can run it on the entire data set, or you can have a windowing approach where you're discarding the previous few months of data, or one day's data. Again, depends on your the experimentation and see how the quality is affected by doing
I think
everything.
this incremental model training, I mean, if you search online, I mean, somebody else asked me and I was looking also, I don't think people can agree on what it means to do incremental model training.
And
so some people do like what is called this champion challenger kind of thing. They just build multiple models. They just train like multiple things on the data, and then just based on that like heuristic, like they pick one, and there is a whole bunch of techniques.
There is this online learning concept, right? My model is getting retrained as the new data is coming. Theoretically, we know, and we know a few companies, including ours, for example, Bing and Google, they do that. Like
Right.
you create a new page, within seconds it'll show up in the search, because we are doing online learning. But again, that takes a lot of finesse and data. Like not a lot of our customers are doing that.
Sure.
It is possible.
Sure.
So
So easier ways to just run through the entire data set in a rolling window,
Yeah.
and every hour go through it.
and from the integration perspective, there is nothing that is stopping you from doing it.
Sure, yes.
That's the point.
Yes, I just wanted to ask from your experience, what do you see customers doing? Last question.
So if you
Yes.
reach out to us afterwards, then I can connect you to people, our data scientists, in-house data scientists who can give you more
Yeah.
educated advice on that.
Sure, sure. I have last question, which is going to be very quick. So, fraud detection, I've heard you've mentioned it as well. One of the very common use cases. If you give raw data, like there are products out there that if you feed them raw data, they can tell you the data points that are the most important from detecting fraud. Is there anything in SQL Server 2017 that out of the box helps you, get to those data points without getting into R and Python? So just, AI out of the box?
Right. So answer is yes and no. Answer is, if you have a package or R code that has been written somewhere, it will run seamlessly in SQL Server ML services. Now, there are a lot of people who do this hyperparameter tuning and identifying the right set of parameter sweeping. There are code and packages available for some of those things, but then again, it is so pertinent to the data set that you have and the model and scenario that you are working on that it might not work as is.
Sure.
So that's why we don't have like a pre-built model for
not
that.
here. Yeah, I think the one other thing I think we are looking at in SQL for other places is Microsoft Research has some algorithms which can actually give it like this raw data, and then it will tell you if this column is an address, or is this column person's name, or is this column a phone number, like that kind of thing. Basically, it will just discover. It's kind of like Excel, right?
Yeah.
Sometimes you can go select a column and then you say flash fill, right? It will go look at the sample data and do it. Similarly, SSIS has some, you give it a file, it will do a preview, right, of the data types. It will infer based on the data. So there are some algorithms we are looking at for SQL also, like what's more for like labeling purposes. Just give some data and then it will tell me what is the domain, what is the kind of values available there, and those. So, I mean, there are probably techniques which will come soon.
So that technology, I think if you guys were in the Azure machine learning talk, they talk about AI-powered data
yes,
preparation.
I didn't get some of that information there.
So they do some of this thing, right? So learning, programming by example. So they look at some examples and then generate the program. So that's a MSR technology that we have implemented in that product. Cool. You asked another question that I was thinking of. Anyways, that's fine. You can catch us first.
Cool, yeah.
Any other question?
Cool, excellent.
Thank you.
Thanks for coming.